and this is my science project. So the question is, we have to find the probability of a rat, the survival probability. So there are two questions. One is the first question, this one. We assume that there is a cat and a rat, both are blind, and they're placed in a square lattice. Well, the first question is that we have to find the survival probability of the rat when they start on the when the cat and rat are on two diagonals, opposite diagonals. Okay, so given L is the length of the box and R is the small grid size and N is the total number of all the boxes. We have to find for two cases probability. Like first, the rat and cat are opposite diagonal, and second, they're at the center. Okay, now grid problem. Find survival probability of the rat. First, we assume that the cat is here and the rat is here. Now, given cat and rat are blind. A. Lattice length L. R is the grid size. N. The total number of cells, which is equal to L square by R square. Assumption. To simplify the problem, we assume that whenever both cat and rat are at a boundary or a corner, we have a provision to wait or not to move. Second assumption. So probability of weight of the cat or rat at four corners, that is A, B and C, D, is 1 by 2. Probability of weighting of cat or rat at any boundary point lies the edge, like this one, this one, this one, and this one is equal to 1 by 4. I represent this as P of up, and so is equal to P of down is equal to P of left is equal to P of right, which is equal to 1 by 4. Assuming cat and rat can make only moves or can just wait. Let us consider a random walker placed at 0, 0 in a 2D plane. Probability of a walker at n1 and n2 in 2D space. Let the walker take a total number of n steps. Assuming it takes x steps in x direction, number of steps taken in y direction is n minus x. Since the total number of steps is n and he already took x steps here, and x minus n minus x is the steps taken in y direction. Probability of a random walker to be on n point after x steps, which is on the x-axis, which is equal to, from binomial distribution we have nc x p power x and q power n minus x. We get the same thing like x factorial by n1 factorial x factorial by n1 factorial into x minus n1 factorial into probability of left raised to the power x minus n1 into probability of right to the power n1. Similarly, probability at n2, which is like the vertical axis, n minus x whole factorial by n minus x minus n2 factorial into n factorial n2 factorial into p of up raised to power n2 into p of down raised to power n minus x minus n2. Therefore, the probability of a random walker at n1, n2 is p of n1 intersection p of n2, which is equal to p of n1 into p of n2, since they are exclusive and independent. Therefore, p of n1, n2 is equal to x factorial into n minus x factorial by n1 factorial into n2 factorial into x minus n1 factorial into n minus x minus n2 factorial into 1 by 4 to the raised to power n. Instead of starting from the point 0, 0, we can start from any point, but probability will not change. Now, x min is equal to n1, which implies y max is equal to n minus n1. Similarly, x max is equal to n minus n2 and y min is equal to n2. Min and max number of steps in x, y directions respectively. Now, actual probability is equal to summation of n is equal to n1, upper limit is n minus n2, and we are summing over p times n1 n2. Therefore, the actual probability is equal to sigma of x factorial into n minus x factorial divided by n1 factorial dot n2 factorial into n minus x minus n2 factorial into x minus n1 factorial into 1 by 4 raised to the power n. Whole I'm summing over the limits n1 up to n minus n2. Now, this is for the just general 2D random walk, the probability. Now, further, now, when the cat and rat can meet diagonally opposite. What is meet diagonally opposite is the cat and rat actually start diagonally, like in the question here. Like the rat and the cat are diagonally opposite. Now, the probability of meet is equal to probability of rat in the 2D intersection probability of cat in the 2D, which is equal to probability of rat in the 2D into probability of cat in the 2D. Since they're independent events, which implies from substituting the above equation, we get sigma of x is equal to n1 up to n minus n2 x factorial into n minus x factorial divided by x minus n factorial into n minus x minus n2 factorial into n1 factorial into n2 factorial into 1 to the power 4 raised n, and similarly this expression for the cat. Now, therefore, probability of meeting anywhere is equal to summation of n1 equal to 0, n2 equal to 0, and n1 equal to n, n2 equal to n, probability of meet. We take a summation because there are a lot of possibilities over a huge range. Now, we just represent the whole equation in this equation. Now, second problem. What is second case is that the cat and rat, they actually start at the same point, the center. And we assume that the cat doesn't eat the rat. The cat doesn't eat the rat in the first place. So cat and rat both start from the middle of the lattice. 1 by 2r to 1 by 2r. Probability of the meeting in the 2D is equal to probability of cat into probability of rat in the 2D. We actually this is actually intersection. I wrote it into because they're actually independent events. No. But from the above equation, this probability of cat in the 2D and probability of rat in the 2D is equal to general probability of a 2D random walk. Since they both start from the same point, probability of meet is equal to summation of n1 plus n2 equal to 0 up to n1 n2 equal to n. And I just substituted the above equation and in this equation. We get the probability of meet, but for the probability of rat to survive, we have to subtract the probability of meet. So P of rat survival is equal to 1 minus P of rat and cat meet. Now, second question. A blind cat and blind rat start on a sphere. So they're here also same two cases. One, the cat and rat are diametrically opposite, and case two, they start at the center. Okay, let's come back. So let us consider a sphere, and this is the xy plane. This is z-axis. Now we consider the coordinates like this. Any point in the surface can be represented by theta with z-axis, alpha with an x and y plane. Explanation. Fix theta. Fix theta and the circle on the xy plane. Data is given in the figure like this, and we can find alpha like in the figure. Now take the circle of the sphere for fixed theta. This is a circle in the 2D space. Probability of alpha. Probability of alpha is equal to arc length by perimeter, which is equal to radius into d alpha by 2 pi r, which is equal to p of which implies probability of alpha is equal to d alpha by 2 pi. Now, probability for angle being theta. Probability implies that for which fixed angle, which angle this is fixed. Area of theta up to theta into d theta by surface area, which implies r into dr into 2ar sine theta by 4 pi r square, which is equal to p of theta is equal to sine theta by 2 into d theta. Now, the probability of theta comma alpha is equal to probability of theta intersection probability of alpha, which is equal to p of theta into p of alpha since they're independent events, which implies combining this equation and the previous equation, we get sine theta by 4 pi d theta d phi. Now, this is for the first case. This one, the first case. The rat and cat are diametrically opposite. Case 2. If number of steps are infinitely large, then the probability of caught is eventually 1, because game goes on till rat is not caught. Hence the probability of survival is 0. If number of steps is less than 2n, probability of survival plus 1. This comes from the case 1. Now this provides the probability of their meet independent of the radius of the sphere. Also, if the number of steps tend to be very large, rat will be eventually caught. Hence, the probability of survival is equal to 0. Thank you.